Ever wondered how we can find the exact area under a curve? Today, we're diving into the powerful world of definite integrals to calculate the area under the curve of x squared plus 2 from 0 to 3. Our first mission is to find the antiderivative of our function, x squared plus 2. Think of this as finding the undo button for differentiation. For x squared, we increase the power by 1 and divide by the new power. For the constant 2, we simply add x, so the antiderivative is 1/3 x cubed plus 2x. Next, we apply the Fundamental Theorem of Calculus. This theorem is our shortcut for finding the area under the curve. It tells us to evaluate our antiderivative at the upper limit, which is 3, and subtract its value at the lower limit, which is 0. Let's plug in our numbers. We'll evaluate 1/3 x cubed plus 2x at 3, and subtract its value at 0. First, we calculate the value at the upper limit, 3. That's 1/3 times 3 cubed, plus 2 times 3, which simplifies to 9 plus 6, giving us 15. Then, we calculate the value at the lower limit, 0. That's 1/3 times 0 cubed, plus 2 times 0, which simplifies to 0 plus 0, giving us 0. Finally, we subtract the lower limit value from the upper limit value. 15 minus 0 equals 15. So the area under the curve of x squared plus 2 from 0 to 3 is 15. In summary, we've used the Fundamental Theorem of Calculus to find the exact area under the curve of x squared plus 2 from 0 to 3. This theorem is a powerful tool in calculus that allows us to solve complex problems with ease.